All right, today we are talking about series and specifically sums of finite series. So we have to review some vocabulary first. First of all, you hopefully remember sequences from last year. So a sequence is when we have a list of terms in a specific order, where we have a sub 1 being the first term, a sub n being the nth term or that general term. A finite sequence has a first term and a last term. And an infinite sequence has a first term and then no necessarily ending term. A series is the sum of the terms in a sequence. A finite series is the sum of the terms of a finite sequence, and an infinite series sums the terms of an infinite sequence. Okay, we also had a geometric series and sequences and arithmetic. Okay. So we'll go over those as we look at them a little more in depth. So we have something called sigma. We have lowercase and capital sigmas. So we're going to be using capital sigmas, and this is called sigma notation. So the sigma is that funny looking E. It means sum. Okay, so the sigma is followed by the explicit formula for the sequence. The small number below the sigma is the first term or the lower limit. Sometimes they don't always start with the first one when you're finding the summation. Sometimes they start with like the 10th term or whatever. Okay, so the lower limit is under the sigma symbol. The upper limit is above the sigma symbol. If it's an infinity, you know it's an infinite symbol or an infinite series. If it's a number, then you know it's finite. And then it tells you to sum them. So it says write out and evaluate each sum. So we have k equaling 2, so that means we're starting on the second term. We're going to end on the sixth term, and we're going to sum it. So we're going to do, so the first one we're going to evaluate is 3 times 2 plus 1, because we're going to take that and we're going to plug them in. Okay, so that's our first one. We're going to add it to 3 times 3 plus 1. We're going to add that to 3 times 4 plus 1. We're going to add that to 3 times 5 plus 1. And we're going to add that to 3 times 6 plus 1. Okay, so that is where our k equals 2 told us where to start, and then the 6 told us where to end. So that would be what? 7 plus 10 plus 13 plus 16 plus 19. When we add those, we get 65. So the sum of that finite sequence that they gave us is 65. All right, this time we have geometric. That first one was arithmetic. So we have 3 to the power of k, and we're starting at 2, ending at 5. So that's 3 squared plus 3 cubed plus 3 to the 4th plus 3 to the 5th. So that's 9 plus 27 plus 81 plus 243. Add this together, we get 360. So when we don't have a lot of numbers to evaluate, it's not terrible. When we get more numbers to evaluate, it gets to be more of a pain. So, says, consider the arithmetic sequence, a sub 1, a sub 2, a sub 3. The sum of the first n numbers in the sequence, a sub 1 plus a sub 2 plus a sub 3 plus a sub n. Well, it's possible to compute such a large sum manually by adding the individual terms like we just did. Such an approach becomes infeasible as n becomes infinite or becomes really large. So there's a simple formula to help us with that. Okay, so it says the sum, they're using S of n, is equal to n times a sub 1 plus a sub n divided by 2. Okay. So note that this formula, we need to know 3 things. We need to know the number n, so the number of terms in the sequence, the value of the first term of the sequence, the value of the nth term in the sequence. Okay, so here we go. It says 3 plus 7 plus 11 plus ... plus 704 equals. So it says compute the sum. So the first one they give us, that's going to be our a sub 1. The last one that they give us is our a sub n. We have to figure out what our difference is because that's going to help us figure out what our n is. Okay, so our difference here, what are we going up by each time? Well, our difference is 4. So we know our last term is 407. So we're going to say 407 is equal to a sub 1, which was 3, plus n minus 1 times d, which was 4. Simplify this a little bit. If we subtract let's distribute first. So 407 is equal to 3 plus 4n minus 4. So 407 is equal to 4n, that would be minus 1. So then we get 408 is equal to 4n, so n is equal to 102. So do we have everything we need? We certainly do. So the sum of the sum of the first 102 is n, which was 102, times a sub 1, which is 3, plus a sub n, which is our last term that we need, all divided by 2. Okay, so the sum of our first 102 is 102 times 410 divided by 2, which is 20,910. Okay, let's try the next one. We have -9, -4, 1, 701. Okay, so it looks like each time, what are we adding? It looks like we're adding 5, so D is 5, A1 is here, AN is there. So AN, which is 701, is equal to A1, which is -9, plus n minus 1 times D, which was 5. So 701 is equal to -9 plus 5n minus 5. So 701 is equal to 5n minus 14. So 715 is equal to 5n. So n is 143. Now we have what we need. So the sum of our first 143, or 143 terms in this sequence, is equal to 143 times -9 plus 701 divided by 2. So that's 143 times 692 divided by 2. So this sum is 49,478. I'm not doing that math in my head. I am using a calculator. Don't panic. Okay, looks a little bit different when we're in sigma notation. This gives us our D value. Okay, this is D. This gives us our AN. This also gives us our N, right? N would be 134. No, that doesn't give us our, that's our N value, not AN. Okay, so we need to figure out A1. It's going to be 3 times 1 plus 5. So A1 is equal to 8. And then our last term, 134, is equal to 3 times 134 plus 5. So that's 407. So now we have the numbers we need. So this sum is equal to the 134 times our first term, which was 8, plus our last term, which was 407, all divided by 2. When we simplify that, put that all on our calculator, we get 27,805. Okay. So here, a sub 1 would be -3 times 1 plus 5, which is 2. A sub 75 would be -3 times 75 plus 5. So that would be -220. So then the sum of this series is equal to 75 times 2 plus negative 220 divided by 2. So that is 75 times negative 218 divided by 2. So that sum is negative 8175. Okay. Now those were just our arithmetic. We also still have geometric. Okay. So it says consider the sum of the first n geometric. Okay, so same type of thing. Here is the formula we're going to be looking at. Here's other formulas that are going to help us. Okay, now the fun thing about this is the way that they write this. It makes it really kind of easy to pick out what we need. There's a little less computation to do. So this is our first term. This is our R value. And this means this is our a sub 6, because our formula is always n minus 1. So that's our sixth term. Okay, so the sum, there's 6 terms. Okay, so it is a sub 1, which was 3, times 1 minus our R value, so our R to the nth. So R is negative 1/4. Our n value is 6. We're dividing that by 1 minus negative R. Okay, and then we're going to simplify all that, throw it in our calculator, use lots of parentheses when you put it in your calculator, and we end up with 2457 over 1024. Okay. Because this would be R is equal to negative 1/4. This would be our n value is 6. Okay, so A1, this is going to be, because that's a 4, that makes this our fifth. Okay, our R is what's in the parentheses, so that's negative 4. Again, our n value was 5. So the sum of this sequence is a sub 1, which was 5, times 1 minus R, which is negative 4, to the nth, which is the fifth, divided by 1 minus R. Okay. Clean all that up. Throw it in our calculator, and that is what we get. When it is in sigma notation, we do have to figure out our first value, our a sub 1. So this is our R, so R is 3. A sub 1 is going to be 3 to the first power, which is 3. And this is our n value, so n is 8. So S of 8 is equal to 3 times 1 minus 3 to the 8th over 1 minus 3. Do our calculations, we get 9840. Okay. Next one, our R value is 1/3, our N value is 6, and our A sub 1 would be 1/3 as well, because 1/3 to the first power is 1/3. So plug it in. Our formula says it's A sub 1, which is 1/3, times 1 minus R, which is 1/3 to the nth power, which was 6, divided by 1 minus R, which is 1 minus 1/3. Clean all that up. I would do the top calculation, get that number, do the bottom calculation, do that number, times it by 1/3. We get 364 over 729. Good luck.